All right, today we're starting section 9.6. We'll pick it up next week since I will not see you tomorrow. We are going to solve rational equations. All solutions to rational equations must be checked to see if they truly work. Often when multiplying an algebraic expression, extraneous solutions are obtained. This is not really a new idea for us, this whole extraneous solutions thing. We've dealt with that before. So this is really just a reminder that we have to check our answers when we solve these problems to see if we end up with extraneous solutions or not. If two expressions are set equal to each other, we call that a proportion, then just write the cross product and simplify. So these are going to be the easier ones to complete. So notice we just have fraction equal to fraction. We can just cross multiply and then solve from there. So let's do that for our first one. Now, when we cross multiply, or even before we cross multiply, what symbols might I want to add to my binomials? Somebody said it. Parentheses. It might be smart to go ahead and put parentheses around any binomials, trinomials, polynomials that you see, because that'll help us when we go to cross multiply. So when we cross multiply, I'm going to be taking 5 times what?
18.
No. X squared minus 1. Remember, when with proportions, cross multiplying, that's diagonally multiplying. So the 5 gets multiplied to the x squared minus 1. We set that equal to the other cross product, which is going to be 15 times what? 2x minus 2. Good. Questions about our cross products? Now, some people forget when they do cross products that there is an equal sign in between them. Some people like to leave these as a fraction for some reason and then are confused about what to do. That would be confusing. We need an equal sign in there. What do you think we need to do now?
Multiply.
Distribute, which does mean multiply. We need to distribute on both sides. We've got parentheses on both sides. What do we get on the left side? Good. 5x squared minus 5. On the right side? 30x minus 30. Questions about this? So far, so good? Well, no. Did we figure out what x is yet? No, we got to figure out what x is. We're solving.
How do you add 30? Or
So I here add 30, which I like.
Add 5.
I'm not sure about adding 5.
5, add 30.
So I need this to be set equal to a certain number if I'm going to be able to solve it, because it's got an x squared. So what do I need this to be set equal to? No. 0. We need it to be set equal to 0 because it's a quadratic because of the x squared. So I liked the add 30 because that's going to help me get that side set equal to 0. Yes, the 30 gets added to the minus 5. Those are like terms. But then it's still not going to be set equal to 0. So what else am I going to have to do?
Add 5. Subtract 30.
Good. Subtract the 30x from both sides. Are there any like terms to combine with that 30x?
25. Oh, no.
No. We've got an x squared and we've got plain old numbers, but we don't have anything that's just an x. So when we go to rewrite this, I'm going to erase so I've got room up at the top. When I go to rewrite this, what is that left side going to look like?
5x squared plus 30x plus 25.
5x squared minus 30x, good, plus 25 equals 0. I need it to equal 0 so that I can continue to solve it. We can simplify this one. That's a good thing to point out. Because if we're going to try to factor it, what's the first thing that we would check for? A GCF. And what's our GCF?
5.
A 5. So I like the idea of factoring that out. What are we left with when we factor out a 5?
X squared
5.
X squared
minus 6x
minus 6x
plus 5.
plus 5, still set equal to 0. Good. We can factor some more.
X plus 6x minus 6.
5 out in front. X minus what?
1.
1. I liked the x minus 1.
5.
Oh, X plus 5.
Plus 5?
Oh,
Minus 5. Good. Okay.
You said 6.
Now, when we factor it, and it's set equal to 0, does anybody remember what the next step is?
Set all of them equal to 0.
Set all of the factors equal to 0. Do I need to set 5 equal to 0?
No.
No. Technically, what you can do is divide both sides of your whole equation by a 5, and it cancels it out. Now, if that 5 had an x with it, then you would need to set it equal to 0, because it's got a variable. But if not, the 5 can just divide off, cancel out, don't worry about it. So we're going to have x minus 1 equal to 0, and x minus 5 equal to 0. So when I solve those, what do I get?
X equals 1, X equals 5.
X equals 1, x equals 5. So those are what I think my answers are, but I need to check to see if they're extraneous. So let's pause here for a second. All right, if we're good with all of that, then I'm going to erase some of my beginning steps so that I can do my checking. Yes, these problems take a little while.
I think we're done.
We've done stuff similar to this before where we've had to factor and solve and check. We just haven't done it where we started off with fractions. That's kind of the new piece here.
This is the longest
I don't know about that. I bet I could come up with a longer one that we've done before, but I won't worry about that right now. Which one of these do you want to check first?
5.
Okay, it doesn't really matter. We have to check them both, but we can check 5 first. So when we check, we plug in a 5 anywhere there was an x in the original problem. And our goal is to see if it comes out to be a true statement. So I really don't want to worry about doing something to both sides of this equation. I really just want to simplify each side and see if they truly come out to equal each other. So let's start with the left side. There's nothing to do in the numerator. It's going to stay a 5 over, how'd you come up with 8?
Multiply 2 and 5 and subtract 2.
Good. 2 times 5 is 10, minus 2 is 8. I'm fine with you doing that all at the same time. Equals 15 over,
9.
I disagree with 9,
I mean,
24. Good. 5 squared is 25 minus 1 is 24. Now we look at these and we say those are not the same fraction. But if I can simplify, I should. So we end up with 5/8. That can't simplify. Equals 5/8. What did we do to the 15 and the 24? Simplified by a factor of 3. So 5/8 equals 5/8. That worked out, so you can like put a little check mark by your 5 if you want. You don't have to write extraneous by it. That one worked out just fine. What do we still need to do? we got to check the 1. So for me, I'm going to erase this work. You should be leaving your work.
So it's extraneous if it works.
It's extraneous if it does not work.
Oh.
If you get it as an answer, but then it does not end up making a true statement, that's when it's extraneous. Or if something just doesn't really make sense.
I think this one's extraneous
Why is that?
because the 15 over 1 equals like 0.
Oh, so we take 2 times 1, we get 2. 2 minus 2 is 0. What's wrong with that? You can't do it. You cannot divide by 0. So I would agree. I would say that this one would have to be extraneous. If you want to just put EXT, that's fine. Okay, that one's extraneous. It doesn't really work because we cannot divide by 0. Even though we would divide by 0 on both sides, it's still, you can see it just doesn't work. Not okay. Questions about example 1? Are you ready to see example 2?
Yes.
Okay. I'm going to go ahead and erase pretty much everything else on the screen here so that I've got enough room. Now, they've already got some parentheses in one of their denominators, so that's fine. I would still recommend putting your other denominator, which is a binomial, in parentheses also. So when we started off, we were going to be taking our cross products. So -4 is going to get multiplied to what? X plus 2. Good. What symbol do I want to write next? Equals. Now, I'm taking 3 times what?
5 times x plus 2.
Good. So, if you want to just go ahead and take your 3 times 5, that's fine. What's 3 times 5? 15, and it still is going to have the whole x plus 2 multiplied to it. If you wanted to distribute your 5 first and put parentheses around that, that would have also worked. 5x plus 10. And then you'd end up distributing a 3. That's fine. Either way, you'll get the same answer. So it really is just a matter of preference. What do we need to do next?
Distribute.
Distribute. So what do I get?
Here, 4x
Plus -8, or we could just write it as -8.
Yeah.
What's on the other side? 15x plus 30. What's nice about this problem?
There's no squares.
There's no x squared. That makes our life a little bit nicer. We don't have to worry about factoring or quadratic formula. We just need to solve for x. So you tell me what you want to do.
Add 15 or subtract.
Okay, we could subtract 15x. Or add 4x. It's up to you. It really doesn't make a whole lot of a difference to me as long as you do it correctly. If we subtract 15x, what do we end up with? Negative 19x minus 8 equals 30. Next step. No. Add 8. If it's not an x squared, we're just trying to get x alone. If it's an x squared, then we need it to be equal to 0. But if it's just plain old x, no x squared around, we can just get x alone. 30 plus 8. 38. My last step to solve for x. Divide by negative 19. What do we get for x?
X equals 38 over
Negative 2. Good. That does divide out nicely. We only got one answer for x on this one, but on the last one, we got 2. Why is that? The last one had an x squared. So remember all those rules about your degree telling you how many solutions you should have, whether or not they're extraneous? Last time we had an x squared, we got 2 solutions. Here, just an x, 1 solution. Which means our check step goes faster. We only have one number that we have to check. What happens when we go to check it? Oh, it is extraneous. If we take negative 2 plus 2, we get 0. And if we take 5 times 0, we still get 0. Same thing or similar thing happens on the other one. So really we end up with negative 4 over 0 equals 3 over 0. That just does not work out for us. So I would put an EXT or extraneous by that answer. Questions about number 2? Are we sure? Warm, fuzzy feelings. Sounds good. All right, let's take those warm, fuzzy feelings and give a couple of these problems a try on our own for a few minutes. All right, on number 3, we start off with our cross products. What is one of them?
Okay, negative 2 times x minus 4.
Good.
And then 2 times x squared minus 2.
Wonderful. All right, when we do our distributing part, what do we get?
Negative 2x plus 8.
Mm-hmm.
Equals 2x squared minus 4.
Good. Now, on this one, do I need it to be set equal to 0 or no?
Yes.
Yes, I do, because
2 squared. 2x squared.
the 2x squared. We got an x squared piece. It needs to be set equal to 0. I personally would recommend leaving your x squared term positive.
So add 2x.
So I would add 2x and subtract 8. Now, notice that I just kind of put the plus 2x off to the side because it does not have a like term. But the minus 8 I put underneath the minus 4 because those are like terms. So I end up with 0 is equal to what?
2x squared plus 2x minus,
Negative 8.
yeah, no,
12.
Minus 12, good.
Did you put the 0 on the other side, or do you gotta?
Yes, if you want to move your 0 to the other side, that's totally fine. It does not matter to me. It's just got to be equal to 0 somewhere. One side or the other. What can I do now?
simplify.
What do you mean by that?
GCF.
Okay, we got a GCF of a 2. Some people like to think about this as dividing both sides by a 2, and then the 2 goes away completely. If you like the idea of keeping it as a GCF out in front of parentheses, that's also fine. What are we left with when we factor out that 2?
X squared plus x minus 6.
X squared plus x minus 6, which is nice because we can keep factoring that.
Yes.
What will that factor into?
X plus 3.
What is it?
X plus 3, x minus 2.
Okay, x plus 3, x minus 2. If you put the minus 2 in the front and the plus 3 in the back, that's fine. What happens to the 2 that's out in front? It kind of cancels out. We can divide it now if we didn't divide it earlier, because 0 divided by 2 is still going to be a 0. So what do we do with what's left?
7 equal to 0.
Set them equal to 0, and then solve. What do we get for x?
Negative 3.
X equals negative 3, and
2.
x equals 2. All right, so I'm going to take away my solving steps over here so that I can check. Remember to check, we go back to the original problem. Which one do we want to check first? The -3. When we are checking a negative, we need to be careful, especially when we are squaring it. Notice that I put my -3 in parentheses, squared. If you square a negative number, it becomes positive. So this becomes -2 over 9 minus 2. What does my other denominator become? -7. The last thing I can simplify? 9 minus 2. 9 minus 2 is 7. Now, would we say that these are equal? Yes. So it does not matter that one of them has the negative in the numerator, one of them has the negative in the denominator. Either way we look at this, this is still -2/7. That make sense? We could pull the negative out in the very front of the fraction on both of them, and it would be the same thing. So we know that this one works, but we still have to check 2. Still got to check 2. So I'm going to, instead of a -3, plug in a +2. 2 squared. 4 minus 2. Okay. And then 2 minus 4 on my other denominator. -2. Now on both of these, what do they both simplify to?
1.
A -1. Good. So is this one extraneous? No. So on this one, they both worked out. So there's really no way of knowing from the very beginning if a solution's going to come out to be extraneous, except to think about what would make your denominators equal 0. So like just looking at our second denominator, what would be extraneous for sure? A 4. Like right away we know if we end up with a 4, it's not going to work out for us. But we didn't, so it's fine. Questions about 3 before we jump ahead in our notes? Okay. At a later time or day, we might come back to that 4th example, but I feel like we're good with the proportion style problems. So now we are going to move on and talk about how to solve an equation that has a sum or difference of rational expressions. Now this whole sum or difference of rational expressions, that's what we were just doing, like what you just took a quiz on not so long ago in 9.5, adding and subtracting the fractions with variables. Remember that? All right. First step, factor the denominators if necessary. That's nothing new. Find the least common multiple, or LCM, of the denominators. Again, that's not really new. That's something that we've done. This is where it gets a little bit different. Multiply each piece of the equation by the least common multiple, or the LCM. So this is different from when we multiplied top and bottom by the same thing. Now we're taking what would be our entire common denominator and multiplying it to all pieces of the numerator of the equation. Again, this will make more sense, like most things that we do, when we see it in an example. Then we'll solve the resulting equation, which honestly should not be too bad. Usually it'll involve distributing, combining like terms, and then deciding, does it need to be set equal to 0, or can we just solve for x? Last step, of course, is to check. Got to see if we've got extraneous solutions or not. Are we ready to give this a try? It is quite a process. We can do it. It'll be just fine. All right. Now, the first thing that we need to figure out is what our least common multiple is. So I agree that 10 would be part of it. What else would we have to have with it? An x. Do we have questions about how we came up with that? So, remember before when we were just finding least common multiples, sometimes we write out the prime factorization and then use the greatest number of times each factor occurs. Remember that whole thing? So either that, or you could think about what would your denominator be if you were trying to come up with your common denominator. And this time we have to consider all three pieces. So, for example, what would this first denominator be missing? What's the first denominator missing? A 5. Is it missing anything else? And if we were to multiply it by a 5, what would we end up with? 10x. If you pick a different denominator and do the same thing, figure out what it's missing, and then multiply it to it, you're going to get the same thing. The middle one is missing a 2. 2 times 5x would be 10x. What's our last one missing? A 5x. 5x times 2 is still 10x. So when it's talking about a least common multiple, our least common multiple is 10x. Do we have any questions about how we came to that conclusion? Once we figure out what our least common multiple is, the directions say, that we just went over, is to multiply each piece, which means each numerator, by that least common multiple. You will not multiply it to the denominator, just to each numerator. Now, on this particular problem, because there's no distributing involved, technically we could go ahead and start simplifying now. But because other problems, well, no, let's just go ahead and simplify now. What will simplify in our first fraction? Or reduce or cancel? What's the same top and bottom? The x's. The x's can cancel each other out. And Emily, what were you about to say?
Well, just like 1 and 10 multiply.
1 and 10 multiply to give us what?
10.
10, which can reduce with what in the bottom?
2.
The 2, so the 10 becomes a 5, and the 2 becomes a 1. So do we have a denominator left that we need to write? No. That's the whole point of this, is to make the denominators go away. So out of this whole first fraction, what's the only thing I really have left that I need to write down?
5.
5 times 1, which is just a 5. Bring down the minus sign. In my next fraction, what can cancel or reduce? X's go. What else? We end up with a 4 on the top. So either way you want to do it. If you want to simplify the 10 and the 5 to become a 2 and a 1, 2 times 2 gives me a 4, or 2 times 10 is 20, divided by 5, still 4. Equals sign drops down. What can reduce on my last part? 10 and 2. 10 becomes a 5. 2 becomes a 1. So what are we left with? 5x. Questions about that step? What do you think we want to do next?
Subtract the 5 and 4.
5 minus 4 gives me,
1.
to get x alone, I'm going to.
Divide by 5.
So x equals 1/5. If you prefer to write that as 0.2, you can. But 1/5 is just as correct. The last thing we need to do, check it. 1/2 times 1/5 minus 2/5 times 1/5 equals 1/2. Now this next part gets a little bit ugly, but it's not all that bad. 2 times 1/5 would give me what? Just as a fraction. 2/5. Minus 2/, what's 5 times 1/5? 1. Now dividing by a fraction is the same as doing what? Multiplying by the reciprocal. So instead of dividing by 2/5, I could multiply 1 by 5/2. Instead of dividing by 2/5, I multiply by 5/2. That would be the reciprocal. Now, if it makes more sense to you to do this with decimals, you can. Use a calculator, that's fine. Get a common denominator, that's fine. So 5/2 minus 2 equals 1/2 is what we have right here. As a decimal, what is 5/2? 2.5, or 2 1/2 would be the mixed number. 2 1/2 minus 2 equals 0.5, or 1/2. So did this one work out? Yes, this one does work. So if you want to put 2.5 minus 2 equals 0.5, and that's how we get it. If you prefer to work in decimals, that's fine. Either way, this one works out. It is not extraneous. Do we have questions about this one before we go on to the next one? Okay. Our first step is to figure out what our least common multiple or least common denominator would be.
15.
What is it? 15x. Again, pick any of your denominators. See what it would be missing from the other two. Multiply it all together. If we were getting a common denominator, it would have to be 15x. So that's our least common multiple. That's what we are going to multiply every piece of this equation by. So 3 gets multiplied to 15x. Minus the 4 gets multiplied to 15x. They're keeping their own denominators. Notice how the denominators do not change on these ones. Equals 1 times 15x, still over 3. Each part of the equation got multiplied by our least common multiple. So now we can start simplifying. What's going to simplify in our first fraction? The x's go. 15/5 reduces to just be what? A 3. 3 times 3 gives me a 9. Minus, what reduces in my next fraction? The x's cancel out. 15/3 becomes a 5. 4 times 5 is 20. Equals, what reduces in my last one? 15, and the 3 becomes 5. So what am I left with? 5x. Questions about that step? 9 minus 20?
-11.
-11 equals 5x. To get x alone, divide by 5. So x equals -11/5, or you can write it as -2.2. If it's easier for you to plug in fractions on this next part to check it, that's fine. Or decimals, whichever one you prefer. Do we want to try it with the decimal this time?
Yes.
Okay. For our check step, we've got 3 over 5 times -2.2 minus 4 over 3 times -2.2 equals 1/3. This one might be a little messy to do with decimals, but we'll see what happens. 5 times -2.2. -11 minus 4 over 3 times -2.2. Okay, this is where it gets a little bit messy doing this with decimals, but if we're subtracting a negative, what are we really doing? Adding. So if you're doing it with decimals, you better have a calculator to be able to help yourself do this next part. -3 over 11 plus 4 over 6.6. If you're trying to enter it all at once, I would put your fractions in parentheses. What do we end up getting now? Now, with a little calculator work, you should get 1/3 out of this. It should check out. The checking part on these might sometimes be the trickiest just because we're not always great with our fraction skills. If you're good with your calculator, that will come in handy on these. We'll take the kind of the weight off of you using the fractions. If your calculator can do it for you. Okay. We need to at least get this one started, even if we're not able to go all the way through and check it. We're going to at least get to our solution. Because on this one, we actually do need to factor one of our denominators. The last one. What does the last denominator factor into? X minus 2, x plus 2. Instead of rewriting the whole thing, I'm just going to rewrite the factored form right below it. Since the other ones don't need to be factored, but I still would kind of put parentheses around them. What is my least common multiple? Or what would be in my denominator if I were getting a common denominator? X minus 2, x plus 2. If I'm getting a common denominator, that's what would be in it. Do we have questions about how we came up with that? What would this first denominator be missing? X minus 2. Multiply them together, we'd have x minus 2 times x plus 2. Same thing here. Is the last one missing anything that the other ones have? No. So that is our least common denominator. So we are going to multiply 2 times x minus 2 times x plus 2. Still keeps its same original denominator. 5 gets multiplied to x minus 2, x plus 2. Keeps its same original denominator. Equals 6 gets multiplied to x minus 2, x plus 2. With its same original factored denominator. So we multiplied each part of the equation by that least common multiple, or what would be our least common denominator. On these ones, I think the canceling part is even easier. What cancels out of my first one? X plus 2's. So what are we going to have to do with the 2 and what's left over? Distribute. So that gives me what? 2x minus 4 plus what simplifies or cancels out in the next one? The x minus 2's cancel out. And what do we have to do? Distribute the 5 to the x plus 2, and what do we get? 5x plus 10. On the last part, what cancels out? X plus 2's, x minus 2's both cancel out, and we are left with a 6. What do we need to do now? Combine like terms. What do we get? 7x plus 6 equals 6. To get x alone, subtract 6. 7x equals 0. So x equals 0 after we divide. Now, time permitting, we should be checking that to see if it works out. Plugging in 0 should not take you that long to check.